Okay, so simplifying radicals is what we're doing today. So similar to what we did yesterday, but just a little bit different. Again, keeping up notes, today's number 20. Today is May the 4th, so May the 4th be with you. You know, as we go through things. So, all right. So let me do this. Let me back up. We had a few people out yesterday. So before we add anything new here, let me just kind of. You don't have to write this down. So this is just going back and reviewing. Just a real quick review of what we're doing yesterday. That basically yesterday we were doing something like this. That we had the fourth root of 16, x to the 20th, and y to the 8th. We said you could basically break it apart one piece at a time. So we're going to do the fourth root of 16. We're going to do the fourth root of x to the 20th, and we're going to do the fourth root of y to the 8th. And yesterday, everything we were doing when it came to these numbers, this wound up being a perfect square root. So if you went back, and again, if you weren't here yesterday, you're using these calculators. If you're doing fourth root on one of these Texas Instruments, you have to give the root number first, and then you hit second, and then the rooftop button that's right here, you push that, and it will give you the x there. So what it does is it puts the 4 up here in place of the x. Okay, and then you put in the 16, and then you get an answer of 2. Okay, and with this part of it, we're going to basically take 4, whatever the index is, divide it into the power. So we're going to take 4 and divide it into 20, which will go 5 times. So that would be x to the 5th. For this one, we'll take 4 and divide it into 8. It goes 2 times, so that would be y to the 2nd. Now, the one thing extra we were doing yesterday that we're not going to have to worry about today was that yesterday, we added in that one little detail of talking about that, that if you got it right here, was that if the index was even, we had to go back and put an absolute value around the numbers if it was an odd power. We're not going to worry about that today, because what they're going to do on this part is that in the beginning is that they're going to tell you for this thing, we're going to assume that everything is positive. And when they say assume positive integers on all these answers, that means we don't have to worry about the absolute value like we were doing yesterday. So today we can just say that would be our answer and we're good to go, and we don't have to worry about the whole absolute value thing. Okay, so here's what we're going to do today. What we're going to do today is that we're going to, when we go through these problems, we're still going to have the same setup here, but it's not going to come out to be these nice, perfect answers. That the answers are going to be just a little bit imperfect when it comes off of it. Okay, now we're still going to assume everything is positive integers on these. So first thing we're going to do is let's do this. Let's do the fourth root of x to the 9th power. We're going to show you what this, just having one number different here is going to be that way. So. Okay, we're going to do just like we did yesterday. We're going to take 4, we're going to divide it into 9. They go 2 times, but the big difference is today that you're going to have some leftovers. That everything we were doing yesterday, we would divide 4 into 20, it went evenly 5 times. We did 4 into 8, it went evenly 2 times. So when you do these today, you're going to go ahead and take the outside index that you have here, go ahead and divide it into the radicand, the exponent that's here, and basically here's what it is. This is going to tell you how much goes on the outside. Basically, this is the outside exponent. And the remainder, since this thing was on the inside to start with, this is going to be your inside exponent. So if you think back to when we were doing, we did the whole Finding Nemo, we had to find your exit buddies and all that stuff. This is basically the same thing that we were doing for that. So that's kind of what you're doing. Now, here's the way the book is going to do this. The book doesn't quite do it this way. So our final answer for this thing would be, we're going to have 2x's on the outside. So we're going to have x squared. You're going to have 1x on the inside. And you just have to remember that whatever the index is that's here, make sure you always carry that index over here. Because I've seen people that would miss a problem because they're like, well, I've got the correct answer. I'm like, yeah, you do, but you forgot to put your index in there. And they're like, oh, that's it? I'm like, yeah, that's it. So the work was correct. They just forgot to go back and put the 4 here that was there. All right, now, if you're looking through Math Excel on these, they're not going to show you this. They're going to show you something like this, but they're going to show it to you different. So, and you don't have to write this down, but just realize that if you go through Math Excel and you miss a problem and you look at the show me an example thing, here's what the book says. That if you've got the 4th root of x to the 9th, what they tell you is that they say, all right, well, tell me the next biggest multiple, or tell me the biggest multiple that's closest to x to the 9th without going over. So the multiples of 4 that's close to 9, you got x to the 4th. If you do multiples of the index, you got 4, 8, 12, 16, that kind of thing. So this one, you could make this out to be x to the 8th. And then they'll say, all right, well, if you can, because that would cancel out and give you x squared. And they say, well, if this one's x to the 8th, you need one more to get to x to the 9th. So then they rewrite it as x to the 8th times x to the 1st. And then they'll simplify this part, but then leave this one like it is. And then they do the same thing. They say, all right, well, 4 going to 8 2 times, so this will become x squared. And then you've got the 4th root of x on this part. It's the exact same thing as doing this, but to me, this looks a whole lot easier. This is easier to explain to somebody how to do it instead of going through and doing this part of it. So it's the same answer here as it is here. The book just breaks it down a little bit different than the way that I kind of look at seeing these. So if you'd rather do it this way, I'm fine with that. To me, this is a lot easier to show someone the work to get the answers that's here. Because as long as you can make the connection that whatever's up here goes on the outside for the exponent, and whatever's remainder here, that remains on the inside, that's your remainder exponent that would go there. To me, that's just an easier way to kind of show going through those. If you want to rewrite it like the book does, it's the same thing. It's just a different way of saying it. Is it 6 of 1 or is it half a dozen? Well, same thing, right? No matter which way we go with it. All right, so here we go. So let's show you a couple more of those. So example 2. Let's say it's the 5th root of y to the 17th. So we're just going to take 5 and divide it into 17. Goes 3 times with 2 left over. Again, all you got to remember is this is what goes on the outside. And since that's the remainder, it remains on the inside. So that's going to be the 5th root of, we need y to the 3rd on the outside. And we need y squared on the inside. Okay. And as long as you can kind of keep that in mind, that all you're going to do is just divide, because it already looks like a division problem with the radical sign. It's almost the same thing as like a division problem, that you're just going to divide this index into this power. It just walks through and kind of does the same thing. And that works no matter if you have, 1 variable or 2 variable or 3 variables. It doesn't matter. You just keep doing the same thing over and over. If it's the 6th root of y to the 23rd, well, we're just going to take 6 and divide it into 23. And some people go, well, I'm not very good with my my division and my numbers. And I'm like, okay, well then just, take your calculator out. Take 23 and divide it by 6. At least it gives you the whole number. Oh, sorry, you can't see it there. It gives you the whole number to know what to do with it. And then you're like, well, what if I'm not good with my math there? Well, go ahead and do 3 times 6. That's 18. So that's the number that you know it's got to go to the bottom. And then you just subtract those 2, and then you got your 5. So you need 3 on the outside, and you need 5 on the inside. So we need y to the 3rd on the outside. And with the 6th root, we're going to need y to the 5 on the inside. Okay. And that's all you got to do. There's no trick questions on this one. There's nothing, there's nothing they're going to do that's going to slide in that's going to be different. The only thing that they could possibly do on one like this is instead of giving you 1 variable, Oh no. Be careful. They're going to give you two variables. Oh no, we've got two letters. What are we going to do? Okay, we'll just do it one at a time. For the x's, you're going to divide 4 into 18. And then for the y's, you're going to divide 4 into 23. 4 going to 18 4 times. 2 left over. 4 divided into 23 5 times with 3 left over. And if you do those kind of on the same level, this tells you everything that's on the outside and everything that's on the inside. And then if you had another variable, if you had a z at the end of it, you could do the z over here. Everything that's on the top, that would be everything, every power that goes on the outside. Everything that's on the bottom, that's everything that's going to be remaining on the inside. So for this one, we're going to need x to the 4th on the outside. We're going to need y to the 5th on the outside. And on the inside, we need the 4th root of, we need x squared and y to the 3rd. Okay, so there's really, and with the simplifying on these, it's not anything they can do that's really tricky on this one. It's just being able to divide this index into this number and then just figuring out how many times it will go and what your remainder is. And again, how many times it goes into it, that's the powers that would go on the outside. Whatever your remainders are, that's going to be your remainder powers on the inside. Okay, and we use that to kind of walk us into the next thing that we'll do, which is almost the exact same thing with this one. It's multiplication. Okay, with multiplying radicals, we'll just kind of, I don't even want to call this step 1 because it's not even really step 1, and they won't give you any that's like this, but we'll just go ahead and put it here. So you don't have to worry about this one because they won't give you a problem where you're going to multiply two radicals where one of them, the index is square root of 3 and the other one is square root of 4. Because if they do that, then you can't do anything. You're done. Problem's over, and you didn't do anything at all. Okay, so you don't have to worry about that one. Step 1, that will be pretty much a given, but that's something that you're supposed to check is that the index must be the same. All right, second thing you're going to do is you're going to multiply the radicands. And if you're remembering yesterday, the index is up here, and the radicands is what's on the inside here. The one other thing you might want to put with that one is if you're multiplying radicands for variables, you add the exponents. And we'll say add the exponents of like variables. So if you've got an x and an x, you can add the exponents together. If you've got a y and a y, you can add the exponents together. All right, step 3, and you could almost make this like a 2a, but we'll go ahead and call it step 3 on this one. And I don't think this is going to happen very often. They'll sneak one in every now and again. But if there are numbers in front of the radicals, and remember, if there are numbers in front of the radicals, we just call those coefficients. Just like if you had 4x squared, 4 would be the coefficient. Same thing with these. It may be you might have 4 times the 3rd root of 5x or something like that. So if you happen to have a number that's out here, that's out in front, then you just multiply the coefficients together. So if there are numbers in front of the radicals, which we call those coefficients, just multiply the coefficients together. You won't get that a lot, but occasionally they'll sneak one in on you where you've got to multiply the coefficients together. And then the last thing that we'll do, which was basically the whole thing we're getting up to, is that you're going to simplify. And you really only have to worry about simplifying the radicand. Because the outside number, once you multiply it together, once you multiply the coefficients together, that number is pretty much kind of done. So, okay. And again, really the first step's always going to be done. And we just put that on there for this one just to make sure we got it. So really everything after that is going to be, you're going to multiply the radicands, the numbers on the inside. If there are numbers on the outside, you multiply those together, and then you break down the radicand as much as you possibly can there. All right, so let's just show you some different examples of what we're going to look at. All right, so let's do the third root of 18 times the third root of 3. Okay, indexes are the same, so step one, again, that, you can basically kind of get rid of that one because that's always going to be the case. Step two, you're going to go ahead and multiply the radicands. All right, now here's where one, and this is kind of a check that you can do. Here's one where you kind of take your calculator on the side because sometimes the numbers are going to be really easy. So this is one where I tell people, okay, before you multiply these two things together, go ahead and just rewrite it as like 18 times 3. Take out your calculator and check and see what that answer is. Because sometimes, let's see, so we've got the third root of 18 times, and make sure you put that in parentheses, 18 times 3. It's third root of 54. If you check that one, that's third root of 54. If that comes out to be just an integer answer, if it comes out to be what we'd call like a perfect cube root, then you can basically just tell me what that answer is going to be. But in that case, this is not. It's 3.77 something on that one. So if this thing doesn't come out to be perfect, then you can't use your calculator. If that came out to be, if we'd done the cube root of that and the answer came out to be 4, well, then we could just put 4 and we'd have the answer. Most of the problems that you're going to do today, well, I wouldn't say most, 50-50. Half the problems you do today, this will come out to be a perfect answer. The other half, you're going to have to take this number and you're going to have to break it down. And the reason I don't go ahead and do this 54 first is because if you go ahead and multiply this together and make this 54 and it doesn't come out to be a perfect square root number, you've got to break this number down. Well, if you're going to break it down, we already had it broken down here, so let's just take this thing and keep on breaking it down here. So that would be 2 times 9, and that would be 3 times 3. So we've got 2 times 3 times 3 times 3. Okay, so we'll break all the numbers down. We simplify everything as much as we can. And because it's the third root, we're looking for 3 of a kind. There's the 3 of a kind right there. So we can take that 3 out. And there's only 1, 2. We need 3 of them to break it out. So that's going to stay the third root of 2. Okay, so that's kind of the process you got to go through these. Is you're going to go ahead and multiply the numbers together. And I would say kind of leave them like this, but then check it with your calculator. Go ahead and do 18 times 3 and make that out to be 54. And check and see if that number works out to be. Because sometimes, and I've seen people that do this in the past, they would go through and take this number and break everything down. And I would say, all right, well, just go back and check your number because you didn't even have to do all that. They're like, what? I'm like, well, let me show you. So say you had to do square root of 40 times the square root of 10. Because neither one of these are perfect square roots. So we're going to multiply them together. So that's 40 times 10. That's 400. So we're going to check the square root of 400. Comes out to be 20. So in that case, you don't have to do anything. You just punch it in the calculator. You just check it and see, because if we did 40 times 10, well, that would be 400. And then we just check it and see, all right, is that a perfect square root? We check it. It comes out to be a nice even whole number. So you don't have to do anything at all on that one other than just knowing, hey, I can put that number in and it came out to be a perfect one. Back here when we did cube root of 54 and we checked it, it did not come out to be just a decimal number or just an integer number. It came out to be a decimal number, and that meant we had to go back and break it down. Okay, so that's kind of what you're looking at doing on these, is multiplying your radicands together. If it's a perfect square root or perfect cube root, hey, that's great. If it's not, then you're going to have to go back and break this thing down. Okay, so we're going to practice on the ones that you have to break down, because using a calculator is easy. You just punch it in, you got it there. So let's show you something that you can do just to practice a little bit more breaking these things down. Okay, so for example 3, let's go with the square root of 8x to the 5th times square root of 3x. Okay, index is the same, so we're good there. So go ahead and put it together. So we've got 8 times 3. And again, 8 times 3 is 24. If we did the square root of 24, that would not be a perfect square root number, so you don't really have to put that one together. Then we've got x to the 5th times x. And I would say on that one thing you want to do, just to be careful, because I've seen people make this mistake, and it was just a simple little thing on that one. Go ahead and put a 1 on any of the exponents that don't have a power, because it's easy just to kind of, if you're getting in a hurry and trying to get through this as fast as you can, which sometimes is, you don't get through it too fast. It's easy to forget that there's a 1 there. So if you do this, you've got to take the 8 times 3 and you've got to break this down. So if we break it down, we've got 2 times 2 times 2 times 3. And with the x's, what we said to do back here was with the variables, we're going to add the exponents of the like terms. So we've got x to the 5th and x to the 1st. So go ahead and add those two together and make it x to the 6th. Okay, and then you can start looking for the exit buddies, breaking things down. You got a pair of 2s. So that 2 will go out. The 2 times 3 won't go out because there's not a pair of 2s and there's not a pair of 3s anymore. So they'll stay separate on the inside. And if you do square root of x to the 6th, well, we're going to take 2 and divide it into 6. And that'll go 3 times with no remainders. So we're going to take an x to the 3rd and put that on the outside. So that'll be 2x to the 3rd on the outside. No x's on the inside, so go ahead and multiply the 2 times 3 together to make that just a 6 on the inside. Okay, and again, you can almost do these one thing at a time. You can worry about just the numbers that you can do, 2 times 2 times 2 times 3, and look at that part, and then you can also do the square root of x to the 6th. No, then you're going to take the 6 that's here and you're going to divide it by 2. Yeah, so you can break it up one piece at a time. If we had one more variable, you could do that one variable separate by itself there. So just think that we're just doing it one little piece at a time as you go through those. On the homework, the button to get, if you've got to do like the 4th root of 5 or something like that, on your homework button, you're going to see a box and then you're going to see a square root like that. That's your button in your homework when you're going through Math Excel. That the button for a 4th root or a 5th root or whatever, you're going to have to use that button that's got the little box right here, and then you just go back and put your number in there. Sometimes occasionally some people have a hard time finding that one, but that's one you can use there. All right, let's give you another one of those. Let's do the 3rd root of 4 x to the 5th y times the 3rd root of 6 x squared y to the 4th. Okay, again, indexers are the same, so you don't have to worry about that part. Just put it all together. That's the third root of, we've got 4 times 6. You've got x to the 5th, x squared, y, and then y to the 4th. And again, just to be on the safe side, go ahead and make that y out to be y to the 1st. All right, you've got the third root of 4 times 6. That's the third root of 24. If we check that one real quick, we're going to do 3, second, root 6 times 4 is 24. That is not a perfect square root, so that one you're going to have to take that number and break it down. So go ahead and just leave it like it is. 4 would be 2 times 2. 6 would be 2 times 3. All right, and since we're doing third root, well, there's your 3 2s, so you can take that out and just make that a 2. And the 3 only has the 1, so it will stay the third root of 3. Okay, and again, we're going to take it just one little piece at a time. We'll get the number first, and then we'll get the x's, and then we'll get the y's and go from there. For the x's, we've got x to the 5th and x squared, so that's x to the 7th. For the y's, that's going to be 1 plus 4, that's going to be 5. Okay, and then for these, all we're going to do is just divide 3 into 7. That'll go 2 times with 1 left over. And for the y's, we'll divide 3 into 5. That'll go 1 time with 2 left over. And to me, this was always kind of good when I got in the habit of doing this one. Is if you'll divide these numbers right underneath the variables when we do this, everything stays lined up because, again, everything up here tells you what goes on the outside. Everything here is what's left over on the inside. Okay, so putting all this together, we've got a 2 that's on the outside here. You need an x squared. You need a y to the 1st, or just a y that goes on the outside. And on the inside, we've got this 3 from the beginning. We're going to need 1x and 2 y's. And that would be your final answer that you're looking for. Yep. One more multiplication with some bigger numbers, because everything so far has been kind of small. That we did, 6 times 4 and 8 times 3. And let's throw a couple of bigger numbers at you just to see what it would look like with some bigger numbers. All right, let's go 45 x to the 5th and y to the 3rd times 35x y to the 4th. Okay, so if we bring it together, it's 45 times 35. X to the 5th and x, and again, I put a 1 on that one just so that you don't forget about it. Then y to the 3rd and y to the 4th. All right, if you check it real quick, I don't know what 45 times 35 is. If you check 45 times 35, that's 1,575. So when you do the square root of that number, so second, square root of 1,575, that does not come out to be a whole number. So we're going to have to take 45 and 35 and break it down. All right, so we start to break it down. 45 is 5 times 9. 35 is 5 times 7. 9 is 3 times 3. So we've got 3, 3, 5, 5, and a 7. So if we break that down, we've got 3, 3, 5, 5, 7. Okay, for the x's, we've got 5 plus 1, so that makes that x to the 6th. And for the y's, 3 plus 4 is 7. Again, I like to when I get to doing that. Most people hate doing variables because we've done that. This is the part where variables are easy because with the variables here, you just add the exponents together and then you go break them down. In this case, it's square root, so we're going to divide 2 into 6. Well, that's going to go 3 times with no leftovers. For the y's, we're going to divide 2 into 7. That'll go 3 times with 1 leftover. Okay, so on the first part back here, there's the exit buddies with the 3's. Exit buddies with the 5's. The 7 stays on the inside, so all this together, that 3 goes together on the outside with that 5. On the outside up here, we need an x to the third. Also need a y to the third. And then on the inside, we've got a 7, no x's, and 1 y. And now the last little thing, and you can kind of do that back here if you want to save a step kind of as you're going through this one. Go ahead and do 3 times 5 and make that 15. So we got 15, x to the third, y to the third, and then the square root of 7y. Okay. In most cases, the hardest thing you're going to have to really do is taking these two numbers and breaking them down. But again, if you don't, because a lot of times people would do 45 times 35 and they'd get 1575, and they're like, well, how am I going to break that down? I'm like, well, how about since you multiplied 45 times 35, start with those two numbers. So that way, if you just check it to see if that was a perfect square root, it was, then you're good. If it's not, just leave it as 45 times 35 and break down these two numbers, because these numbers won't ever be that big that they'll be hard to break down. Now if it's 1,575, yeah, that would be tough to break down, but we're just breaking down these two small numbers, so hopefully they won't be too bad. Okay, and then the last thing we've got to do, which is just, and this won't be very long, this will be just a short little thing here, is we're going to do division. And there's 2 parts to division. We're going to do 1 part today. The next part we'll come back and pick up in a couple of days, because we're going to do adding and subtracting tomorrow. And then Thursday, I won't be here, so you'll have to go to gym 2 with Coach Turnbow, because I got to go give an AP exam that day. Okay, so dividing radicand or radicals, we're going to go ahead and assume that the indexes are the same, because if they're not, again, there's nothing you can do. So we're just going to assume that step 1 is done for us, because if the indexes aren't the same, then there's pointless to do anything else. Okay, just like with the multiplying, you had to multiply the numbers. Same thing on this one. You're going to divide the radicands. Whatever the numbers are on the inside, divide those 2 numbers out. And then step 2, if you have variables, no, we're going to do everything backwards. When we're multiplying, we added the numbers, the variables together. With division, you're going to subtract the exponents together. So we'll say subtract like variable exponents. Okay, and then just like we did with multiplication, you look to see if you can simplify it. More than likely you can. There'll be some where you won't be able to. Okay, so let's give you one that's straightforward and really easy here. Okay, so let's say we're going to do the square root of 80 over the square root of 20. Okay, so all we're going to do here basically is we're going to take 80 and divide it by 20. That's 4. Square root of 4 is 2. There you go. And somebody's thinking, well, they're all going to be that easy. Well, no, they're not all going to be that easy. They're going to make you think on some of these. Some of these, they might even be, I don't want to say a trick question, but they'll be that easy, but you look at the answer and you go, well, that can't be it. So let's say you got the third root of 6 over the third root of 2. Okay. Again, the index is the same, so we're good there. 6 divided by 2 is 3. With the third root of 3, there's nothing you can do to break that one down because you would need this to be 3 to the third so that the index and the root would cancel. So for that one, that's all you can do. Just third root of 3. There is no simplifying on that one because there's nothing else you can do there. Okay, let's give you one with some variables in it. And again, the variables won't be hard because again, this will be one where it should be pretty easy to work through. Let's do the third root of 15x to the 7th over the third root of 5x to the 6th. All right. 15 divided by 5 is 3. And with the exponents, we're just going to subtract. 7 minus 6 is 1. And the third root of 3 won't simplify with the x. Now if that had been bigger, if that had been like x to the 4th or the 8th or something, we'd have to take the 3 and divide it in that one. But for that one, that's as far as that'll go, so that's as much as we can do. All right, one last problem, and I'll show you the setup for a word problem, and then that wraps up for today. Let's do the square root of 270 x to the 7th, y to the 9th over the square root of 6x to the 4th, y squared. Okay, first thing is, if you're not sure about 270 divided by 6, well, just check it with your calculator. 45. And then subtract your exponents. You've got 7 minus 4 would be x to the 3rd. 9 minus 2 would be y to the 7th. Okay, and that's your halfway point. At that point, that's the correct answer, but you've got to put it in simplest form after this one. So here's where we're going to take each part and break it down. We're going to break down the square root of 45. We're going to break down the square root of x to the 3rd, and we're going to break down the square root of y to the 7th. Okay, 45, start to break it down. The first thing I'm thinking is that's 9 times 5. And now, the reason, if you go with that one, 9's a perfect square root. So if you take the square root of 9, that would just be 3. So that would be 3 squared of 5. So if you're breaking the numbers down, if you start with 45 and you break it down, and let's say you're doing 9 times 5, if you run across a perfect square root number, remember, you can go ahead and take the square root of that one. And if you can break this one down farther, you can. In this case, we weren't able to, so that would be as far as we'd have to go with that one. All right, with x to the 3rd, again, if it's square root, that's an understood 2 that's out here. So we're going to divide 2 into 3. I'll go 1 time with 1 left over. And for the y's, we're going to divide 2 into 7. That'll go 3 times with 1 left over. Okay, and then we're going to put it all together. So we've got 3 squared of 5. So we've got a 3 on the outside. We've got 1x on the outside. And we've got 3 y's on the outside. So remember that top number up here, that's always the exponents that go on the outside. Everything that's left over, well, since that's the remainder, those have to be what's on the inside. So we've got a 3, x to the first, and y to the third on the outside. On the inside, we've got 5, and then x to the first, and then y to the first. Okay. And again, to me, the hardest part on these is simplifying the numbers that you have here. A little bit of work here, but if you get the hang of that, you're just dividing this index into this exponent. And again, the top number is your outside exponent, the bottom number is the remainder on the inside. Then if you can get that, then it's okay. All right, and then the last thing, and you'll need this for one of the questions in the homework. The formula for area of a triangle. Anybody remember what it is off the top of your head? There you go. 1/2 base times height. Or you could say base times height divided by 2. And in the homework, they're going to give you a really easy problem. They're going to say, all right, the base is this much, the height is this much, and then they're going to say, what's the area? So as long as you know that formula, you multiply those two numbers together, you divide it by 2, and then you've got the answer that you're looking for to go through that. So that's about it.